Okay, so this class, it's not bad. It's not bad. Most of you did answer it, which is fine. Hopefully these will change. How does your feel for trig change if you ignore your feelings about trig identities?
No, they go up if I'm only talking about trig identities.
Oh, see, that's interesting. I found that out today for some of the other classes. Some of the kids really like trig identities, which is great. I think there's a certain purity to them. I mean, purely terrible or purely nice. I mean, you get this really great feeling when you finish. You're like, oh man, that worked. And I told you about my best idea for a test ever, right? Was that in this class? Oh man, I told it in C block. I'm gonna give you a test. I'm gonna get 3 trig identities. Maybe, which one isn't a trig identity? Run you in circles. That'd be so cool. Because you never know if it's wrong or not. I think it's perfect. So, what did you think of the lighthouse problem?
I don't know how to do.
Gives you a nice triangle, right? You have point A and point B. What does it tell you about the distance from A to B? And what is it? 12 degrees and? And you know these are right angles. So what do you fill in first? Yeah. That's it, right? And the first thing you need to find, and if we call this, I don't know, we'll call this S right here. What's the first distance you need to find? AS. And AS, what's a great way to find AS? Using what? Law of sines. How about this? Sine of 60 over AS is equal to what? Exactly. Who got that answer to 3 decimal places and can tell me AS to 3 decimal places? 3 decimal places. Brooke.
3.5.
Correct.
So you don't want
I just want 3 decimal places. 3 decimal places, 3 decimal places. Or round that last one. The AP test accepts both answers. If you chop it off or if you round that last one, 3 decimal places, it's fine. But when you do this, please, you're probably going to have to use this value somewhere else, maybe. So immediately store it as a numerical value, as one of the letters. Sorry, as one of the letters. So then you have to find, what's the next distance you have to find? BS. Anybody have that to 3 decimal places? Someone new? Cochran. Yeah. And store that as well. Now, the last thing you need to do is find which distance. Oh, I need to label this. Yeah, so you need to find PS. Now, to do PS, what should you use? What's an easy way to do it? What?
Sine 60.
Is it just sine of 60?
Times R. Times the second.
Which one?
Well,
this look. Wait, hold on. Sine of 60 degrees is equal to opposite over hypotenuse, right? So that's going to be PS over what? BS, which we've stored, which you do this out. So PS is equal to BS sine 60 degrees. And we have BS because it's right here, right? So what does PS equal? 3 decimal places. Anybody have it? New? Someone different? Yeah. 2.5 what?
3.
3? Is that correct? Is that to 3 decimal places? 2.53?
2 after it.
2.5. I think it's, yeah, I think there's a 2 after it, I think. This one's pretty good. So are we pretty good on law of sines and cosines? Pretty good? You don't have to. No, there's different ways to do all of these. Yeah, there's always a longer, there's always a proper way to do it in a longer way. Sure.
You have to use, like I use X for from the P to...
Yeah, there's a lot of ways to make it harder. There's a lot of ways to make it longer, yes. And with that statement, let's work on to the ultimate way to make things longer if you really want to. The backside, trig identities. They're great. Okay, we're going to use hands. We're going to use hands. Use hands, kids. Someone raise their hand and let's pick one to start with. Brooke is right there. Number 19. Sure thing. So there are different ways in which you probably have been taught how to handle these. I'm going to obliterate some of the things you have been taught because I don't want you to make careless mistakes, and also you're in Precalculus. So I want to go with true logic here. You can work on each side independently. Never work on both sides at the same time, ever. Do not. Stop working on one side, work on the other. It's really easy to do something illegal. What's really nice about these is all of these they do work. The book isn't lying to you on any of these. So yeah, I know the trig identities will verify, right? So you can't skip steps. It's the work that matters. So for this one, let's just go from left to right. What could be the first thing we do to the left? Yes. So we're going to write as in terms of what? Yes, this is one big thing you can always do. This can be very helpful. So what is it going to be? 1 over theta minus? Yep. Stop there. Now what? Yeah, you have a common denominator, so let's put it together. Now, you suspect you're going to have to do that because how many fractions do you see here? 1, so you need to make one fraction. What's the problem now, though?
The wrong thing for his number.
Yeah, it's close, right?
Okay, there's nothing you can multiply.
Always something you can multiply by. No, well, no. You can multiply by something that will result in a flipped answer, kind of. What's the number you can always multiply by? 1 or a form of 1. So you have to pick. This is the challenging part. How many different forms of 1 are there? Many. You have to look at this and say, oh, okay, what am I going to try multiplying by? It has to be a form of 1, so it's the same thing on the top and the bottom. So that's what we're going to do. Multiply by... Now here's the thing. If you multiply by sine over sine, you get sine cosine on the bottom. Is sine cosine really in anything? It's not in really any of the nice trig identities. It's in some of the addition, subtractions, like sine alpha plus beta. Do we really want to go there? You don't go there unless you have to go there. That's what I was getting at. In AP Calculus, sometimes you do have to go there, but you end up going there so frequently sometimes that it's like, oh, you start recognizing it. Same thing here. What are we multiplying by? No. I want it in terms of sine and cosine. If you multiply by cosine over cosine, that's a good idea, but what do you end up on in the numerator? Still sine cosine, right? I'll give you a hint. We're not multiplying by 1 minus sine over... Let's try this and see what happens. Let's just see what happens.
Of course.
No, it might not work, but you do still have that problem, but let's see what happens. Let's just check it, okay? Let's check and see what happens. What happens to the top? You get 1 plus sine theta minus sine theta minus sine squared theta all over cosine theta 1 plus sine theta. Here's a tip I'm going to give you right now that will make your life much easier. Yeah, here it is. Do not multiply out unless you must. So look at the top. What happens to the top? It becomes what? Yeah, this becomes cosine squared theta over what? What cancels? Boom, and you're left with? Magic.
Those are fun. I don't know how to do them, but they're fun to watch.
Well, it's nice because you get it did work. It did work. Yay. But the magical step here is the magical step, multiplying by a form of 1. You will do that frequently. It's kind of called the, you see this, it's the opposite reciprocal. You see, remember complex numbers, a plus bi? The conjugate. You remember complex conjugate?
No.
You remember imaginary numbers?
Yes. No.
All imaginary numbers are for this form. A plus bi, right? A is the real part, bi was the imaginary part. If you multiply by the conjugate, which is a minus bi, do you remember what happens? It turns into a real number because the I goes away. Because what happens here, you end up with a squared minus abi plus abi minus bi, b squared, I squared, right? This cancels, but what is I squared? What is it? Negative 1. So you end up with a squared plus b squared. This equals a squared plus b squared. Is there an I in there? No, it's a real number. Think of this as the conjugate. What's the conjugate of 1 plus sign? It's not technically a true definition, but you're looking to simplify. Also, what is the most common identity you're going to use? one of the Pythagorean one of the derivations, the result.
Theta plus cosine.
Sine squared theta plus cosine squared theta is 1. So building cosine squared is great. Building sine squared is great, especially if it's 1 minus one of those things.
We're keep sounding like an idiot. Theta represents...
Angle.
Okay.
The same angle.
Oh, okay.
The same
Wow.
angle.
All right. I didn't think it through.
Mission accomplished. Good. Okay. Who wants to pick a second one? Hands. You didn't need to because we made it into the right part. We needed to turn the left into that, and did we do that? Work on one side, and if you get stuck, go to the other side and see if you can make the other side look like what you're at. What? Didn't use a hand. Chamberlain. 15? Okay, we can do 15. Did you try 15 and it didn't work?
No, I did.
Did it work?
Yes.
Then let's skip it. Find me something that you ran into a wall into.
Oh.
Solnit.
I did 15, but I had to subtract something. 21.
No, I don't want to do. I don't want 15. Turn it into sine and cosine, and it collapses. Cochrane. 44. Yeah, let's do 44. I understand. Didn't use a hand again. It's okay. What number did you say, Cochrane? 44. Secant theta minus cosine theta over secant theta cosine theta.
Symbols are so different.
Ain't that the truth? Our symbols. Hummers and french fries. Everybody else's symbols, something culturally valuable.
Have you read?
What do we want to do? What do we want to do? We're going to work on the left and go to the right. What do you want to do first here?
Change it all to sine.
Yeah. So we have 1 over... You guys, I was wondering if that was going to come up. First thing you need to do, did you copy it down? Right. It's so frustrating because if you spin your wheels on these, I mean, if you change a plus or minus, what happens to the identity? Yeah, boom, it fails, and that's how I make a really cool test. What do I do now? Can someone tell me what I should multiply by? There is a proper answer to this. Your opinion is invalid.
Cosine theta.
We get theta minus this? No,
Nope.
1 over.
Nope. You can only multiply by a form of 1, kids.
Cosine theta over cosine theta.
There you go. You said it properly. Thank you. Say both the numerator and the denominator. That's what you multiply by. What does it turn into? 1 minus 1 plus. Right? And what is that? Da, 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 da. You're done.
And the left side of
Wait, why did we multiply by cosine?
Because we hate fractions, right? So multiply by the denominator and it just kills everything. Look, cosine nukes both of this and this, turns that into a square. Carpet vomit. Yeah. Chamberlain, you can try again, yeah. Which one? 31. Do I want to do 31? Okay. What do we think of 31? 1 minus sine theta over cosine theta plus cosine theta over equals. Okay. Let's work on that left. How many fractions are on the right?
Well, you're what? You can say it's 1.
How many? Just as it's written right now, how many fractions do you see? None. I mean, technically, if you write in terms of sine and cosine, it's 1. How many terms do you see on each side? 2 on this side, 1 on that side. So we're going to need to combine the terms. Sometimes it's beneficial not to combine the terms. In this case, we will need to. Well, we can't write it in terms of sine and cosine because it is already written in terms of sine and cosine. In order to add fractions, what are we going to need? A common denominator. But what common denominator do you want to work towards? Let's just play around for a little bit. I'm going to try to get you to recognize places where you can kind of shave time off this. Instead of trying to pound out a common denominator, let's try to actually make the common denominator into something that is already there, which you can do more easily with trig. Things tend to fold in on themselves. For example, when you see 1 minus sine, what's automatically one thing you should think at this point? Cosine squared. You want to build cosine squared, right?
Sine squared theta.
Yes, but watch. Look, if we leave this alone right here, and we multiply this by 1 plus sine theta over 1 plus sine theta. What happens? Well, this, what happens to that? Nothing happens to this, right? No, stop. Can you just watch for a sec? What does this turn into? Cosine theta times, remember, are we multiplying that out? No. Over cosine squared theta, right? And what happens? That's gone, right? Do you have a common denominator now? And what happens to the numerator? You have 1 minus sine plus 1 plus sine, so what do you end up with?
Oh, you wait.
2 over cosine theta, which is 2 secant theta. Why do I what? No. We multiply by 1. You can multiply by 1 wherever you want. It doesn't matter. I left what I saw here. What I saw when I saw this. I looked at this one right here and I saw, oh, 1 minus sine. I can bounce that into cosine squared, right? Cosine squared is going to cancel with that cosine on the top. That gives me forward momentum. And look what it nicely does. The signs cancel when you add them together, and you're just left with 2 over the common denominator, which is now cosine. Are there longer ways to go about this? Absolutely. You could try to build a true, initially a common denominator of cosine times 1 minus sine, blah, blah, blah. It'll collapse, hopefully, if you don't make an algebraic mistake. This, I'm trying to get you to zone in on the quickest methods. I don't know of a quicker method than that. Anybody see one that looks a little different, that might be something different or more heinous? There are some really terrible ones on this sheet. Using hands, Brooke. It's not bad. We can do that one though. Do you wanna try a really nasty one? 51 is bad enough. Why did I write that? I don't know. That's a 5. Oh, I was combining that. Okay, 51. Secant theta minus cosecant theta all over secant theta cosecant theta. And we're proving that equals sine theta minus. I know, Americans are weird, I know. Secant, cosecant. Yeah. Well, guys, they get confused enough with the basic trig. Let's just keep it like that, okay? What do we do? Yeah, translate. What's secant? 1 over times what? Now here's the question. We're going to multiply by something, right? Can anybody tell me what I should multiply by? Yeah, you know. It's a really easy thing you can multiply by.
Cosine theta times sine theta.
Over.
Cosine theta.
Thank you. Look what happens. What happens to the top? What does the top become? Sine theta minus theta all over what? All done. Look, this times this, the cosine cancels, you're left with just sine, right? This times this, the sine cancels, you're left with cosine, right? This is that. It cancels, you're left with 1 times 1, which is 1. Kaboom. No, these are... No, they're multiplied together. They're multiplied together. They're not separate entities. No, look. If you have A times 1 over BC, that's equal to A over BC, right? If it makes you feel any better, what can you do? You can do this, and you could make it like this. Like that. Multiply them together. You see it now? Yes.
Can you quickly explain how to solve triangle without subtracting something from both sides?
Yes. Write it entirely in terms of cosine. What is sine squared? Make that substitution. Done. No, there's lots of different ways to do it. I'm just saying he asked me for one method. I gave him one. There's tons of methods for that. Okay, so you want to do a fun one?
You should always trust the internet.
Work on the right side. It works really well. What's interesting is that's a great question to try going from the left. It's much harder going from the left. You can do it. What did you do from the left?
For the left,
Yeah. You multiplied by? What did you multiply by? 29. What did you multiply by on the left? Over. Been teaching a while. Never seen that before. Yeah, go ahead.
Is there a way to add an exponent in without multiplying?
Nope.
So you have to multiply.
I'm telling you, the only way I know how to do this one is you have to multiply the left side by a form of 1, and you guys have not figured out what it is yet.
It's
But there's no way to add in.
1 over cosine.
Not
over
really.
1
Not in the
over
way you
cosine.
want. Not in the way you want.
Is it like this? 1 over cosine over 1 over cosine.
No. Maybe there's a long way to do it. The quickest way that I know how to do it, you're going to have to, this is something you have to think about tonight. This is part of your homework tonight. Good luck. To what? Just sine and cosine, right? So it's 1 over cosine squared theta. I got to really write that out longhand if we're going to do this. Well, actually, no, wait. We're going to sine and cosine. I'm not going to. Minus sine squared over cosine squared. Plus what? Sine over cosine all over what? 1 over cosine. What should I multiply by? Let's just do cosine over cosine and see what happens. If we multiply by cosine over cosine, we end up with 1 over cosine minus sine squared over cosine plus what? Sine all over 1. So what did we actually end up with now? We ended up with, so that's secant theta minus, and we're trying to turn it into two terms, right? Minus sine squared theta over cosine theta plus sine theta. And what are we trying to prove that this equals? We want it to be sine theta plus what? Cosine theta? We almost there? Well, we have sine theta, right? We have that. So we want to take this right here and simplify it somehow. Well, what's the common denominator here? It's 1 over cosine theta. So we have 1 minus sine squared theta over cosine theta, which is equal to what? Squared theta over cosine theta, which is? There it is. Again, this is first draft work. This is not something you hand in as final draft. This is us meandering. So does that make sense, everybody? What was the magical step here? Well, just multiplying by this. And what happens? Oh, the denominator turns into 1. Kills it, and it works. That's nice. Your homework tonight, everybody, I'll give it to you right now. Your homework tonight is going to be 3 questions. 25, 33, and 42. I don't know. You decide.